little bit of a preview that Nick Stark tried before he left and blacklisted our whole room's IP address within 5 minutes on the WAF. So I know how to fix it. Let's start with an intro here. Apologies for the very Sanjus slide up in front. Just ignore all of the stuff on there outside of the title. This is a preview of a presentation that we're giving at the Cloud Security Summit in San Diego next Tuesday. If you happen to be there, come find me. It'll be a little bit warmer there than here, I imagine. Quick intro, if I have not met you before, my name's Eric Johnson. I do some SANS instruction, author courses for them, mostly in the application security realm. The content that we're going over today has driven a lot of the secure DevOps content that we've got in the new Dev 540 course. So I will leave that at that. If you have questions about that, feel free to hit me up and ask me outside of that. I do kind of training and speaking stuff about 30–40% of the year. When I'm not doing that, I just do independent security consulting on my own at a small company called Cypress Data Defense that's headquartered out of Denver. I write a lot of code still. I come from a development background, so that is still a passion of mine. Most of the tools that I write anymore are dedicated mostly for security purposes rather than, you know, real actual code that would run on the internet, that type of stuff. That terrifies me now that I met Tom. So contact info's on the slide. I'll pull that up here a little bit later. Let's take a quick peek at the topic for tonight, which honestly is continuous security is what we're calling this. Monitoring and active defense. This is a very cloud-focused talk. This actually, in my opinion, is much easier in the cloud than it is in your traditional on-prem kind of deployments, and we'll look at some tools and some things involved there. We'll look at number one, real quick intro, insufficient logging and monitoring. What is that? Well, everybody has this problem for the most part, whether we want to admit to it or not. Monitoring and active defense, we'll look at what our definition is, and to your disappointment, no, it is not hacking back against your attackers like everyone wants it to be. And then section 3 is all for you. We're going to do what I'll call a purple team engagement, where you're going to hack my AWS infrastructure if you want to. I have built in some traps and some honeypot endpoints and some WAF blocking and some fun charts and graphs that will show on the screen as you're trying to hack in, and we'll see what I, as the blue team defender, would see if you were all trying to break into my stuff. And if you get in, we'll talk about maybe what I could have done from a monitoring perspective to detect and defend against whatever that attack is. So that's the bulk of this. I'm going to go through section 1 and 2 pretty quick so we can get to the fun part. At the end, we'll do kind of a quick post-mortem together, and we can all, you know, just raise hands or, you know, shout it out or whatever and say, hey, man, this is what I tried. I hacked your WordPress instance, and this is what I did to do it. Sound exciting? All right, let's start cooking. So, insufficient logging and monitoring. Is anyone familiar with OWASP? A couple hands go up. Everyone's heard of these guys. Okay. They added a new item this year. They finally released the 2017 update, and number 10 on the list was insufficient logging and monitoring. What in the world does that mean? It means we have no visibility. I like that description. We do not know what is going on inside of all of our things, which from a network perspective, we're doing pretty good at that. You know, we do our flow log analysis. We look at our data from, you know, accepts, rejects. We kind of have a very good network visibility typically on inside of our SIMs, at least in most organizations. But from the application perspective, who's looking at Nginx log files every day to see what requests are coming in, what are failing endpoints being tested? Has anybody done that recently? A couple hands go up. How many times do you get scanned a day? You see just some rogue scanner hammering your site, looking for /WP admin or my PHP admin or whatever. It happens a lot. I'll show you some graphs here of this AWS stack that I put together last week. And in the 6 days that I have gotten this whole thing put together leading up to tonight, I have had 3 or 4 different scans from different bots, and I've got a good blacklist of IP addresses going in my firewall already. So I'll show that to you as we come up. The idea is we're not looking at our logs and not using the data in those logs to help actively defend our stuff. So we'll kind of go through what that can look like. But first, if anyone's ever heard me speak before, I usually like to start off with a couple of examples of why we should care about this. So we've had some S3 problems lately. Has anyone seen that in the news? I can tell you from a personal perspective, we have a application, one that we help defend. We do lots of code reviews and pen tests on it. And a developer installed a Java filter in this web application. Does anyone know what a Java filter is? It's kind of just some code that runs on every single request. Inside of the filter, the engineer put a debug logging statement that logged the entire request and the entire response data to an S3 bucket. And this wasn't ever going to actually be turned on in real life. Has anyone seen code like that before? Oh, it's only going to happen in debug. This would never actually happen in production. And guess what happened? We had a problem, so we turned this thing on, and then guess what? We forgot that it was on because it would never actually be on in real life, so why would we even think to look for that? And guess what permissions were on the S3 bucket?
Just everybody that's got an account.
Anyone that can use Google has permission to read from this bucket. Now here's where it gets interesting. This was a financial organization, heavily regulated, and all customer data in some of the requests, remember it's the entire request, like the whole post body, that has all of the account information and all of the customer details are being logged into this bucket for months, to the point where we have 1.5 million customer records that have accumulated into this bucket.
I'm sure they had logging of the bucket.
Now, that's where it gets interesting. And you're thinking, this is a disaster, right? We've got to make some filings with the OCC. We've got to go talk to potentially the SEC. The whole game that Equifax should have played. They're up next, don't worry. So we did find that, yes, auditing and logging on the bucket was enabled, and we had legitimate proof that not a single one of those records had actually been touched by any of you with access to Google, which is very nice. And we got a good lesson learned from that, but it could have been worked, right? From an active defense perspective, we'll talk about maybe what else we could have done to maybe alert us ahead of time if maybe that had happened. So, food for thought. On the slide behind me is a bunch of other things that have been publicly announced, like our drone and surveillance military data being in a public S3 bucket. That might be good to log, potentially, maybe. Does anyone disagree with that?
Information wants to be free.
Information does want to be free, yes. Deep Root Analytics published, has anyone voted before? Yeah, your information in an S3 bucket. And then we had Nice Systems that dumped, 14 million Verizon records out in a bucket as well. So opportunities for improvement, we'll call that situation. And then we'll move on to our friend Struts, which happened to have a remote code execution vulnerability. This is not news to anyone, hopefully. Did everyone know Equifax got hacked? No! They just told us last week. So, same situation. 140 million credit card or customer records leaked out. All of our fun, social security numbers are burned. And that was through a Struts endpoint that was vulnerable to remote code execution, which allowed our attackers to pivot to a different server and make 140 million requests for all of the customer records. Remember the topic of tonight. What very simple thing could we have been doing to catch maybe the first 150? Logging and auditing and monitoring and actively defending against anomalies when things like that happen. So just a couple of examples. What do they have in common? Well, let's just say the auditing and logging was insufficient, just like the OWASP folks tell us. So no one's either logging the information, we don't have it, or we don't know where it is, or no one's looking at it, or we have no automated detection of when some sort of an event like this is actually going on. This involves a lot of different groups. Has anyone heard of this whole DevOps thing? Couple hands. So if you look down the application stack from Equifax, all three of those groups probably needed to be involved in order to catch that in real time. That's why it's the new hotness. Is because, yes, the application team needs to know, I need to actually audit events when a customer reads their entire profile, and then that would accumulate 140 million times into a log file. And then the operations and security teams need to know, well, where is the log file? How do I get that into my central point of collection, we'll call it? Because it's an ephemeral instance and I blow it away, guess what happened to our audit data? Bye-bye log, which the attackers would love to do that.
If it doesn't log, it doesn't happen.
It didn't happen. If you don't have a log file, it didn't happen. Absolutely. So some things to think about. This is kind of where we're heading here as we go into our definition of monitoring and active defense. And I know it's not what some folks would want it to be. We're not actually allowed to go hack our attackers back, at least in this country. Yet. So Robert Emily is another SANS instructor. He does all of the ICS curriculum work, or a good amount of it. He has an active defense. Think of the 504 of ICS is essentially what his class is. And this is his definition from a white paper up on the screen. And it's us monitoring, responding to, and learning from, and applying our knowledge to threats internal to the network. Why do you think I bolded internal?
If they're external, you're breaking the law.
If they're external, you're breaking the law. So that's a good kind of line, in my opinion, to stay with it. At least right now, until they make that legal. Okay, so where do we start? Does anyone love data? We all love data. We need it.
Is that big data?
Big data. Yeah, you could. This is big data just because that's the topic of the day, right? And it's a buzzword, which everybody loves. So in the cloud, at least in the infrastructure that I put together, I picked some easy points to say, here's where my data is. Does anyone use AWS regularly? Got this stuff down? Yeah, we love it. Are your flow logs turned on?
No, probably not.
So we've got these things called VPCs. These are virtual private cloud networks, and they offer us some very good information in terms of flow, traffic flow, accept, reject, IP addresses, source, destination, the size, all of that aggregate information can feed us a lot of really cool details to help us monitor and defend our perimeter. We've also got CloudFront distribution log files. We've got application load balancer log files, and then, the old just server log files. So we'll talk a bit about what these look like real quick here. Here's what a very small section of a VPC flow log file looks like. We've got these being dumped into CloudWatch from our VPCs, from our NACLs, from our actual network interfaces, and they send out the packet counts, the data sizes, the accept, reject, the source, destination, IPs, and ports, all of the fun information that, might be good to monitor for anomalies. So that's one chart I'll show you here in a little bit that we put together. We've also got CloudFront, which is their Akamai, if you want to call it that. It's just a CDN, and we get lots of good information from CloudFront. This is stored in an S3 bucket as compressed text, and we get the endpoint that somebody tried to hit, the verb, the response code, user agent, what TLS protocols they tried to use. Sound like good information that, we might want to be taking a look at?
Does it give you the JA3 yet?
The JA, no, I don't believe so.
Ask for it.
Okay. I've got a lot of pull at Amazon too.
It's the handshake. It's the handshake of the client to the server.
Oh, interesting.
It's basically it's like a SHA hash of like the cipher suite and the order in which the cipher suite is doing the hello to the service.
Okay, well, let's look. Could it be this? No. No, okay, we're just checking. I haven't seen that yet, but I also haven't looked for it either. Okay. JA3. All right. I'll take a look. Load balancer, same drill. Stored in S3 is compressed text. We've got more TLS cipher info, not our JAW 3, I don't think. TLS certificate, user agent, the game goes on, and then yes, we've got our app server logs that I bolded a word on this slide because in the cloud, these don't live very long when your instance only lives for an hour. You have to actually do something with them to get them off of the thing that you're going to kill. So whether you're putting that out in, an elastic file storage, or you just have some job that syncs them into an S3 bucket or whatever, we have to make sure we do that to retain the data to get the information I'm going to show you here in a bit. Now, if you haven't really gone down this path yet, there's a cool project out there called Monitoring Sucks. Has anyone used this before? It's a perfect name because it does suck. It's hard. And you can go out here. They've got 7 or 8 different Git repositories as part of this organization. And you can look at all the tools that they're saying. You can use these tools to help you automate this. There's a metrics catalog to say, hey, by the way, for your network or your app server, we've talked about, these are the metrics that you need to make sure you're logging. And it gives you the tools to do it. And now you've got the data, because that's the data that you need in order to build upon it and start actively defending the network. Here's some examples from the metrics catalog. We've got example, anything over HTTP, port 80. So it's saying, yes, you need to be logging the request byte size, the response byte size, the response code, the durations, and it gives you lists like that for HTTP, HTTPS, all the different protocols, network, web, app server, databases, if you've got MQ servers. It gives you all of those things that, might help you start thinking down this path. And then we can start turning that data into meaningful metrics. So the response code I called out specifically. If you get a slew of 404 errors, like 100,000 of them, what does that mean probably from a security perspective? Yeah. Someone maybe is running Dirbuster against your website looking for all those endpoints. We'll play the game again. If you get a bunch of 500 errors, what does that mean? Well, it could mean that you royally screwed something up on your last deployment and the whole site's broken. There's always that chance. Us security folks are thinking, well, we're getting attacked. They're putting some sort of an injection payload in some place and it's causing this error. You can also track user agents, and you can start picking up scans from tools like SQL Map or Nikto or W3AF. Nmap, I guarantee you, is being tracked in our site that we're going to attack because, does anyone know Jared McLaren? He was helping me test this earlier, and he blacklisted himself very quickly by running an Nmap scan against our server. So we know that that's being tracked. So food for thought, if you want to lock everyone else out of the room, just fire up Nmap real quick, and you've won the DOS game. So what are some challenges here? We can have too much data because, well, we love to collect things, right? Is anyone a data hoarder? A couple hands. We all are in weird ways. Humans are not actually great at manually parsing log files. I know we're all brilliant, but no one has enough time in their day to actually dig through this stuff and look for these things. So what do we need to do in order to digest this very quickly? Scripting, tools, dashboards. And if you see an anomaly, then we can actively react to some piece of information and make an adjustment and defend things. So your goal should be to end up with something like this. This is a screenshot that I took from one of the dashboards I've got set up on our system earlier today. Now it's kind of funny, and I know it's probably kind of small, but if you look towards the top left, you can see I've got a massive spike at about 1.1, so about 1,100 requests into a CloudFront distribution on, I think that was like February 9th, last week sometime. So I stood this instance up on the 8th, And on the 9th, somebody actually found this thing I threw out on the internet and scanned it with over 1,000 requests, just, seeing what this site was all about. So I picked up on that anomaly within a day of me launching it out into the world, before I told any of you about it. So it's kind of interesting to see. We've got here's how many requests that the WAF has blocked. We've got some other automations. I've got some Lambda invocations, which I'm using for blacklisting IP addresses and things. So you're getting this nice visual snapshot of the activity going on within the system. And then we can start to defend ourselves. So in the AWS world, has anyone used the AWS WAF before? A couple hands go up. What do you think? I've used a lot of WAFs, and in my opinion, it's quite a bit better than some of the ones that I didn't do anything with this. I turned it on. How many WAFs, when you turn them on, are secure by default? Because usually they're in passive mode, or you have to train them in learning mode, or they break everything. So, in my opinion, it does a pretty good job. And Nick and I over there, we were running just running manual requests, not automated at all, and it blacklisted us twice. So it's not really very friendly, I guess I'll put it that way, to the attacker. So what it's got in it integrates with our load balancers and our CloudFront distributions. It's got built-in rules for SQLi and or cross-site scripting. You can add customized rules. We've created some that look for CSRF tokens and just deny requests if they're missing tokens. You can also go to the marketplace, which this is pretty new. There's now a WAF rule marketplace where you can go look at other people's WAF rules. I would just caution you before you download the random WAF rule from the market to, read it before you install it. That whole supply chain vulnerability problem we're running into, like Struts, for example. It's got an API for automation, and it's got lots and lots of lists associated with it. So that's our automation for this part of it. So the GitHub repo for their security automations project is on the slide, and it actually does quite a bit. It's got IP reputation lists built into it. You turn it on, and it goes out to spam hosts, emerging threats, and Tor exit node distributions, and it automatically loads about 12,000 blacklisted IP addresses into the reputation list. That's pretty cool. It also has built-in flood protection. If you run a scanner against this WAF, you will get blocked. There is an automation threshold. I can't actually remember what I picked when I set it up, but it must be fairly strict. It allows you to manually whitelist and blacklist IPs, and it's also got a log parser built into it. So it'll go out and look at log files from CloudFront and from your load balancers, and it will look for anomalies and automatically blacklist IP addresses if you do some evil things. So it's got some of that auto defense built into it. So here's the drill, at least the diagram, for you visual folks. And it's using Lambda to manage a lot of this automation for us, which are just very short little functions that you can write, and I'll talk about Lambda here in a moment. So if you come out here, and I almost need a laser pointer because I'm too short to reach all the way up to the top, but we've got auto-deployed with this as a HoneyNet endpoint. So it creates an endpoint which invokes a Lambda function, and if you go to this endpoint, it automatically invokes the Lambda function, which takes your IP address and then backloads it into the blacklist. So what could you do with that HoneyNet endpoint that would be kind of fun from a blue team perspective? Does anyone have honey tokens in their apps?
Hell yeah.
Why not? They're beautiful. So if we put a link in a page that's hidden with a nofollow attribute on it and somebody follows it, what does that tell you? It's a bot or a spider that's kicked off from a scanner that is invoking that endpoint. So it's an easy way to scrape bots and automatically blacklist their IPs. Just a word of warning, when we get to the fun part, I may have dropped some honey tokens into the web page. So take a peek at that. So here's our slide about our endpoints. Everyone knows Target Lady, right? It's one of my favorite SNL skits of all time. So we've got this endpoint hidden. You can put them in HTML comments. You can put them in hidden links and custom headers. That invokes the API gateway, which in turn invokes the Lambda function, which lands you into the blacklist, which is kind of a cool active defense chain. So here is the diagram that zooms in on this a little bit, just this piece. And serverless is how we're pulling this off. Does anyone love to write code? I know Tom does. So much code. So some security folks get kind of nervous here on the code writing part. If that is you, then just go find a developer to help you write it. So it's about 200 lines of code, this function. You could have written it in Python, Node.js, C#, Java, or they just added Go recently. So you can go write this whenever you want. And the idea is it should do something like this. You look at the environment, and if that is ALB, then you make one call into the CLI called WAF regional. If not, you call into WAF, and you just add the IP address straight to the IP set for the bad bots, and that's it. And you've taken that IP address, and they can no longer get to your site. How simple is that? So that is the active defense internal to our network. We're looking for those anomalies, and yes, you need to be confident that bad things are happening before you just start blacklisting everybody. But the idea is you can start to build your defenses actively just based on log data. Who thought logging could be so much fun? Then we get to the fun part. So here's what we got set up for you. You're going to hack. I'm going to put my dashboards up on the screen, and we'll see what happens. So here's what I set up. Now, this isn't just me opening up vulnerable servers. We had to make it fun and challenging. So I went out to AWS, and I found, now everyone knows that PCI means you're completely secure, right? Absolutely not. Yes. So what I did is I took the PCI Data Security Standards Compliance CloudFormation Starter Kit, and I launched it out into the world. I didn't change anything. I actually disabled WordPress because it just didn't work. So I turned the app stack off. And then I deployed my own WordPress stack into the VPCs that it created. And I'll show you a diagram here in a second. And then I took, has anyone played with OWASP Juice Shop project yet? Nobody? Oh, it's awesome. One hand. So it's a Node.js application, and it's just like WebGoat, except it looks cool, and it's modern, and it's not written in just plain Java servlets, which is great. So that is out in an instance within the VPC as well. So you've got kind of 3 different targets that you can play with. I have put the templates that I did change in this Git repo at the bottom of the slide. So if you want to tinker with them or launch them out and kind of redo this on your own, eventually, hopefully I'll get to the point where the dashboards are auto-created. I did a lot of them manually just because of time constraints. But here's what you're looking at. So there is a Linux-based Bastion server, which is just a jump box in the cloud Amazon world, that's over in a management VPC. So I'm going to give you that IP address. You can bang on that instance as much as you want. See what ports are running. There's no WAF there. So you can scan away on that thing. That instance, if you happen to break into it, has NACLs that allow it to get into the other VPC that's hosting all of the web resources. Inside of the web resources, we've got a WordPress instance that is hosted in 2 subnets that is load balanced out to an app tier which has 2 instances running WordPress, which then have 2 redundant database instances running the WordPress database. So this is actually a pretty redundant template. I mean, that's a full scale, I really don't want WordPress to crash setup. What I did on top of it is I added AWS WAF out in front of it, which is going to throttle a lot of your automated scanners. Now, one of you is going to run an automated scan, and it's going to blacklist you, and just tell me when it does, because the whole room is going to get blocked out at that point, unless you have a VPN you can jump onto or something. I'll undo it. I'll actually disable the WAF eventually, but I want somebody to trip it because I want a picture. And then Juice Shop is also running in that production web tier. here's the URL to the Juice Shop project. This is not as redundant as WordPress. It's running through a CloudFront distribution. It's in an instance with an instance backing its origin, and this is just running in a Docker container. So Docker is kind of touchy. So if you're going to scan this and it crashes, just let me know and I'll try to restart it. But what I am telling you is that automated scanners are not going to work very well here. The WAF will kill you off. So you're going to have to use the old-fashioned manual fingerprinting and playing with repeater, etc., whatever you want to use on the web app side. I guarantee you there are a ton of vulnerabilities in Juice Shop if you poke at them long enough. So here's your URL. Here we go. I used a shortener. I actually used Google's URL shortener, and right after I created it, it told me I was in violation of their EULA, and it blocked the link out. I don't know what I did wrong there, so bit.ly is what I used. And you can go out to the site. This is the home page that you can see. It should say monitoring sucks, and there's 3 bullets that give you the IP address of the Bastion server and the 2 CloudFront distributions that you can click on, and you should be able to get to them. And you can start playing. Now, there are some rules. I had to ask Amazon for permission to do this, and they sent me a very strict email back that said, do not DOS our systems. So no denial of service attacks. No protocol flooding attacks. Don't send UDP flooding attacks to the server. They'll kick us all out, and I don't think I can fix that one. And no resource flooding, no HTTP flooding, that type of stuff. Other than that, do whatever you want. If something breaks, it should auto-scale back up and replace the broken instance, but we'll see. And what I'm going to do is put the dashboards on the screen so we can look through some of these things. And you can see this is a flow log chart that's up on the graph right here. Let me zoom in on this a little bit. This is just over the course. We're set at, let's see, that's a week. Let me go back to 3 hours. And you can see this is over the course of the day so far. I've had a couple people banging on this, and you can kind of see those peaks and valleys of just the accept and reject traffic.
Can you repeat the rules again?
No DOS.
Okay.
No protocol flooding.
Now, by DOS, we mean bandwidth exhaustion or like straight denial of service?
Straight denial of service. The bandwidth, yeah, and this is in the cloud. If that's a bandwidth problem, I'm pretty sure that this room's bandwidth will limit us before AWS's does.
Okay, so no denial of service, HTTP flooding, or?
Yeah, no protocol and no resource flooding.
Define protocol.
Do I need to? Do you want me to pull the email up?
No, that's okay. So HTTP flooding or protocol flooding?
Yep, HTTP flooding, TCP, UDP flooding is more the protocol side.
Okay, I'll do that. So
Yep.
no DOS.
Yep.
I'll leave it at that. No HTTP flooding or no TCP, UDP flooding.
Yeah, that will cover the majority of the bullets that they gave me.
Thank you.
What I have found so far is if you run anything automated at the CloudFront distributions, it's probably going to be blacklisted before I even get back to look at it.
No automated BS.
Yeah, you can run Nmap, but it will, what I will tell you is you can run Nmap against the Bastion IP. There's no WAF there, but the WAF is pretty strict about automation.
Nmap okay.
On the Bastion instance.
Is that the URL that you gave?
That, yep.
Okay, I'm not doing that. Okay.
Let me pull the page up.
I didn't pay attention to your talk.
There you go. No, that's all right. So here are the resources. The IP address doesn't have a WAF on it. The 2 URLs are sitting behind a WAF. And when it gets blocked out, I'm eventually going to whitelist the IP for the entire room so we don't get blocked out again.
So the bit.ly though, I can hit that with so long as no HTTP flooding, no protocol flooding, no DOS.
Yep.
Okay, sweet. That's on Twitter now. Thanks.
And I'm just going to watch. So the goal here is I want to see how good these charts and graphs are actually doing at detecting your attack signatures.
There's no plugins on your WordPress. That sucks.
There are no plugins on WordPress.
Oh, there's a denial of service though.
Yeah, no DOS, Tom, no DOS. I'll let you struggle for a minute, and then I'll show you the Easter egg I put in there. So we can play with this for as long as we want. Is a half an hour good, do you think? What time do you guys usually get out of here?
9 o'clock.
Oh, so we've got time then. And I'll pull some of the fun stuff up here. If you want web app vulns, Juice Shop is definitely the way to go.
Should be seeing some things in the chart.
Oh, yeah. Request counts going up. Are you hitting WordPress or the Juice Shop?
Yes,
All right, WordPress.
I'm hitting both. So you only allow key-based authentication in your secure shell. That's the only port open on your. So I'm looking for a private key.
Yep,
Right? So that's
absolutely.
currently what I'm looking for.
Yes, you are. Now, this is the PCI default. I didn't do anything to that server except launch it out into the world.
Oh, PCI.
You know, and there might have been a URL that I showed you that.
I missed the URL.
Search for the PCI Quick Start template and look in my GitHub repo.
Come on. Too much pressure.
Ooh, look at that.
When you submit, it doesn't restart your 2 seconds. It's a timeout. So like, you don't send it data for 2 seconds. Yeah. If you send it the wrong thing, then you're wrong on your again.
We're trying to bring it to the right way.
There's only.
I keep getting spoiled.
You're not doing it right.
Okay, fair enough. Can you check this off?
Yeah, I'm getting complaints about returning a connection.
Follow-up question?
Yeah.
One win or what do you got there? Without the
There are.
It's working. It's working this time.
Okay, so let me go tell Trey open. Do you want music going right now?
What's that?
Do you want music going? Like
You can put music on or whatever.
hey,
What time? Like 8:15?
850 is when we wanted to do the CTF walkthrough.
Okay, so
More than an hour.
I probably have 10 to 15 after.
Oh, we're blocked.
Oh, yes, got to get a picture. Who did it?